We have a new fossil planet. A new study reports the discovery of an ancient icy world that formed early in the solar system's history. It is the first new member of a rare group of objects known as sednoids in nearly 2 decades. But what is it? And why do astronomers call it a fossil? Let's dive into this story together. When I say the word planet, most people think of Mercury, Venus, Earth and Mars, the rocky worlds that orbit close to the Sun. But our solar system extends much farther out. It contains dozens of known icy bodies called trans-Neptunian objects, or TNOs, which orbit beyond the planet Neptune. Discovered in 2003, sednoids are a very special kind of TNO. They have highly elongated, eccentric orbits that come close to the Sun every few hundred years and then venture far out into the frigid outer solar system before returning once again closer to the Sun. Sednoids were initially thought to be dwarf planets that had once orbited the Sun, much like the dwarf planet Pluto, but whose paths had been altered by a large unseen planet, dubbed Planet 9. This intriguing hypothesis proposed that Planet 9 exists somewhere in the outer solar system and gravitationally perturbed or nudged these objects onto their strange orbits. In 2022, a study claimed to have found hints of a dozen such hypothetical rogue planets. However, some astronomers remain skeptical until we can spot Planet 9 directly if it really exists. Several studies have sought to use the alignment of sednoid orbits as evidence for Planet 9's presence. If the alignments are real, they could be explained by a perturbation caused by Planet 9's gravity. Enter Ammonite, a newly identified sednoid with a highly eccentric orbit that ventures far out into the solar system's frigid reaches. What makes it so special, and how does it challenge the Planet 9 hypothesis? Let's find out. Ammonite, formerly 2023 KQ14, was first sighted in data collected by the Dark Energy Survey in 2018, but its status as a sednoid was only confirmed this year by the Subaru telescope. Subaru is a 8.2-meter diameter telescope located at the summit of Mauna Kea in Hawaii. As part of the international team behind the discovery, astronomers used Subaru to precisely measure the object's position. But why did the team decide to name this icy world Ammonite? The name stems from the Latin word for cosmic fossil. There's a good reason for that, which we'll get to in a bit. First, let's take a closer look at the object itself. Ammonite's orbit is highly elongated, stretching out to about 5 times the distance between the Sun and Neptune, before swinging back in closer to the Sun, reaching as close as the orbit of Jupiter. Interestingly, its orbit is tilted relative to the Sun by nearly 40 degrees. In contrast, most known sednoids orbit the Sun in nearly the same plane as the planets, with only minor tilts. This unusual tilt means that Ammonite does not pass close to Neptune's orbit. When it swings inward toward the Sun, since Neptune has the largest mass in the outer solar system, its gravity should have significantly influenced Ammonite's orbit if the two objects had ever gotten sufficiently close to each other. However, because of its large tilt, Ammonite remains far from Neptune's path as it passes through the outer solar system. And since it doesn't come close to Neptune's orbit, Neptune's gravity cannot have played a significant role in shaping Ammonite's current orbit. This lack of influence is key to understanding why the discovery of Ammonite calls into question the Planet 9 hypothesis. You see, one of the main pieces of evidence used to support the existence of Planet 9 was the clustering of several sednoid orbits in a region of space known as the Outer Solar System S reservoir. Proponents of the hypothesis suggested that Planet 9's gravitational pull had pushed these objects into their current tightly grouped positions. However, Ammonite's non-aligned orbit weakens this argument because it shows that not all sednoids orbit the Sun in this way. It suggests that trans-Neptunian objects may have formed in a more complicated way than astronomers previously assumed. Moreover, Ammonite's orbit is similar to those of some comets, hinting that it may have shared a common origin with them. If true, this finding would imply that the early solar system was a bustling place with countless comet-like bodies zooming around. Over billions of years, most of these icy travelers have ventured so far out into the cold expanse of space that we can no longer detect them. But a few, like Ammonite, have returned to the inner solar system where we can observe them. Interestingly, Ammonite also shares similarities with another recently discovered object named Fargo, which was identified in 2021. Both objects have orbits that bring them close to the Sun every couple hundred years and then retreat to the distant outer solar system. However, unlike Ammonite, Fargo's orbit is aligned with the other sednoids in the reservoir. What's more, both objects appear to have highly reflective surfaces, suggesting that they recomposed of ice and other volatile compounds that can vaporize when exposed to the Sun's intense heat. Altogether, these findings suggest that sednoid-like bodies are a diverse bunch, challenging the idea that they all originated from a single massive collision early in the solar system's history. Instead, the data seem to indicate that these objects formed in a more complicated way and that the early solar system was a dynamic place with many different populations of icy bodies. For example, it's possible that some sednoids like Ammonite originated in the outer solar system and never ventured much closer to the Sun, while others migrated inward due to gravitational perturbations. This migration could have left a trail of icy debris in their wake, giving rise to the Kuiper Belt, a vast disk of icy rocks and dust that surrounds the Sun beyond Neptune's orbit. Eventually, some of these bodies could have collided with Earth and other planets, delivering water and organic molecules that played a crucial role in the emergence of life. So why did the researchers refer to Ammonite as a fossil? Well, the outer solar system is like an archive of the solar system's past, because it has unchanged much over billions of years. Sednoids like Ammonite are like time capsules, preserving clues about the conditions that existed in the early solar system. By studying these icy relics, astronomers hope to piece together how our planetary system formed and evolved over time. That's why Ammonite's discovery is such an exciting development. It provides a unique opportunity to probe the formation and early history of the solar system. Now, it remains to be seen whether future observations will reveal more sednoids with similar properties to Ammonite. If they do, it could provide further evidence against the Planet 9 hypothesis and shed light on the more complex origins of these enigmatic icy worlds. Ammonite's discovery also highlights the incredible capabilities of ground-based telescopes like Subaru. Despite being located on a small planet, Subaru can peer deep into the cosmos and uncover fascinating secrets of the solar system and beyond. It's me. And if you want to learn more about the amazing discoveries made by Subaru and other telescopes around the world, stay tuned for more updates. Until next time, keep looking up. The research was supported by a grant from the Subaru telescope. Subaru is operated by the National Astronomical Observatory of Japan. The discovery was also supported by the Strategic International Collaborative Research Program from the Japan Science and Technology Agency and the Ministry of Education, Culture, Sports, Science and Technology of Japan. The research was published in the journal Science. Thanks for watching.